Let's do section 9.1, page 445, number 13. The problem reads, the sequence in the exercise is arithmetic. Find A, the common difference, B, the eighth term, C, a recursive rule for the nth term, and D, an explicit rule for the nth term. And our sequence is 1, 3 halves, 2, 5 halves, dot, dot, dot. So to begin with, we know that this is an infinite sequence because we have these dot, dot, dots here. And part A asks us to find the common difference, which is t. And to do that, we need to look at the difference between the terms. So 3 halves minus 1 is 1 half. 2 minus 3 halves is 1 half. So we see our pattern developing here, and we can say that D is going to be equal to 1 half. So that's part A. Part B, I'm going to go up here, asks us to find the eighth term, or A8. Now we can use the general formula that we came up with earlier, which says that AN is equal to A1 plus n minus 1 times D. And what is A1 again? Right, it's the first element or term in the sequence, which in this case is going to be a 1. So let's find A8. So we're going to have A8 is going to be A1, which is 1, plus, and every time I see an n, I'm going to substitute in an 8. So I'm going to have 8 minus 1 times my difference, which is 1 half. We found that in part A. So we're going to have A8 is going to be 1 plus 7 halves, which is going to be 9 halves. And that's our answer for part B. Now, part C asks us to find a recursive rule for the nth term. Now remember that recursive means that the element in question, AN, depends on the element before it. And we had a general form for this from our definition of arithmetic sequences, which said that AN was equal to AN minus 1 plus D. Really, if we're going to write the recursive rule, the only thing we can do is substitute in for D, which in this case is a half. So there's going to be our answer for part C, the recursive rule. Each element is equal to the element before it plus a half. And then finally, part B says to find an explicit rule for the nth term. Now, earlier when we were finding the explicit rule, we started with that general formula that we had, which said that AN was equal to A1 plus n minus 1 times D, the same formula that we used up here in part B. And we're just going to substitute in the things that we know and then do some algebra. So AN is going to be A1, again, the first term in our sequence, plus n minus 1, I'm going to leave that alone, and D is going to be 1 half. And I'm going to do a little algebra here. So I'm going to have 1 plus n over 2 minus a half, which is going to give me n over 2 plus a half. And we just want to clean things up a little bit. So AN is going to be n plus 1, the whole thing over 2, and that's going to give me my explicit definition or my explicit rule for the sequence.